In today's lesson, you will learn what happens during melting and boiling. We can explain the change of state of matter by looking at the energy of the particles. In the previous lesson, you have learned that the forces of attraction is the strongest in solids, causing particles to be closely packed together. The particles have the least energy and cannot move freely, but can only vibrate in their fixed positions. In a liquid, the forces of attraction between particles are weaker, causing particles to be able to move freely in the liquid and slide past each other. In a gas, the forces of attraction is the weakest, causing particles to be far apart and move freely and rapidly in all directions. Before we look at what happens during melting and boiling, let's define some terms first. Melting refers to the process when a substance changes from a solid state to a liquid state, and the melting point is the temperature where the solid starts to melt. Boiling refers to the process when a substance changes from a liquid state to a gaseous state, and the boiling point refers to the temperature when the liquid starts to boil. Next, let's look at what happens when a substance, such as ice, melts. When ice gains heat, the water molecules start to vibrate faster and the temperature rises. When ice reaches the melting point, water molecules gain enough energy to break the forces of attraction between the particles, and the solid ice melts into liquid water. The temperature stays constant during melting because the heat supplied is used to overcome the forces of attraction between the particles instead of increasing the energy of the particles. Let's summarize the process of melting. Before melting, the temperature increases when heat is supplied. Particles vibrate faster as they gain energy. At the melting point, the particles overcome the forces of attraction and move out of their fixed positions to slide past each other. It remains constant during melting because the energy taken in by the particles of the solid is used to overcome the forces of attraction between the particles instead of raising the temperature. Next, let's look at what happens during boiling, such as the change of state from liquid water to gaseous water vapor. When the liquid gains heat, the water molecules start to vibrate faster and the temperature rises. When water reaches the boiling point, water molecules gain enough energy to break the forces of attraction between the particles, and the liquid water boils to form gaseous water vapor. The temperature stays constant during boiling because the heat supplied is used to overcome the forces of attraction instead of increasing the energy of the particles. Let's summarize the process of boiling. During boiling, the particles gain energy and move faster and further apart until they overcome the forces of attraction between them and move far away from each other. The temperature remains constant during boiling because the heat energy taken in by the particles of the liquid is used to overcome the forces of attraction between the particles instead of increasing the temperature. To the end of the lesson, so check your understanding of the topic by trying out the quick check questions in your notes.